1.1 Angles. Basic terms, degree measure, standard position, coterminal angles. So some basic terms we're going to go over. Two distinct points determine line AB. So that's what a line would look like. A line segment, AB, is a portion of the line between A and B, including points A and B. Ray AB is a portion of a line AB that starts at A and continues through B and on past B. An angle consists of two rays in a plane with a common endpoint. The two rays are the sides of the angle. The common endpoint is called the vertex of an angle. So you have your initial side and your terminal side. Your initial side stays put. It doesn't move. Your terminal side is what moves up and down. Positive angles. The rotation of the terminal side, if an angle is counterclockwise, that's going to be positive. So if you open up counterclockwise to the left, that's a positive angle. Negative angle is just the opposite. The rotation of a terminal side is clockwise. So if we move the terminal side, it's going down. That's our negative angle. The most common unit for measuring angles is the degree. A complete rotation of a ray gives an angle whose measure is 360 degrees because it's a full rotation, aka it's a circle. So a circle is 360 degrees. 1 over 360 of a complete rotation gives an angle whose measure is 1 degree. Angles are classified by their measures. You have an acute angle that's between 0 and 90. You have a right angle that's 90 degrees, obtuse angle that's between 90 and 180, and then you have a straight angle which is just 180 degrees. So you might notice a new symbol there, a symbol that you've never seen before. If you're like, what are you talking about? I'll highlight it for you. That symbol. That symbol, it's called theta. It's called theta. It's like a circle with a swooping line through it. It's called theta. Theta. Theta, it just means x. It just means a variable. So if you look on your calculator, you see where it says next to the green button, x, t, theta, n? See how they all mean the same thing? It just means variable, but now we're just using theta as our variable. For an example 1, for an angle measuring 40 degrees, find the measure of A, its complement, and B, its supplement. So complement, remember that's 90 degrees. Remember that it's angle 1 plus angle 2 equals 90 degrees. Angle 1 plus angle 2 is 90 degrees. And then supplement is angle 1 plus angle 2 equals 180 degrees. That might be jogging your memory up a little bit. So for part A, to find the complement, we would just do 90 degrees minus 40 degrees, and we get 50 degrees. So the complement to this angle is 50 degrees. For B, the supplement to this angle, we would just subtract from 180. So we have 180 degrees minus 40 degrees, and we get 140 degrees. So the supplement to this angle is 140 degrees. Don't forget the degree, the little degree symbol. That's really super important. Don't forget it. Up until this point, every other teacher or professor probably haven't cared too much, but for trigonometry, you have to put this degree symbol, because later on when we go through chapter 3, you'll realize why we have to put that symbol. So just get into the habit now and put that little degree symbol. All right, we're going to do the same thing. We're going to find the measure of each marked angle. So for part A, we have a complementary, which is 90 degrees. For part B, we have a supplementary, which is 180 degrees. So if you feel confident enough, if you kind of remember geometry a little bit, I highly suggest that just try. Pause the video, even if you're not comfortable. Pause the video and see if you can work out A and B. I really want you to. It's going to be a theme through my videos of I will ask you to pause it and try it, just like if we were in class. Okay, so pause it and try it. I hope you did. I hope you tried it. Let's work it out together. So for A, with complementary, for complementary, it's angle 1 plus angle 2 is 90 degrees. So angle 1 is 6x, angle 2 is 3x, and they're supposed to equal 90 degrees. So we have 9x equals 90 degrees. We divide by 9, so x equals 10 degrees. Now that's not the answer, right? We have to go back and plug it in. So we have to plug it back in. We have angle 1, which is 6x. So that's 6 times 10, which is 60 degrees. Angle 2 is 3x. So 3 times 10, we get 30 degrees. There is our answer. We have a 60 and a 30. All right, so for supplementary, it's practically the same thing, except our number is 180. So we have angle 1, which is 4x, angle 2, which is 6x, and it's supposed to equal 180 degrees. So we combine like terms to get 10x equals 180 degrees. Divide by 10, and we get x equals 18 degrees. So just like before, we have to go ahead and plug it into both angles. So for angle 1, we have 4x, so 4 times 18, and we get 72 degrees. Now let's find angle 2. It's 6x, so 6 times 18, and we get 108 degrees. If you find one angle, so you see how we found the 72? You could have just done 180 minus 72, and we would have gotten 108. So you could also do that to find the second angle, but I'm just trying to reinforce, you got to plug in x to find those angles. Degrees, minutes, seconds. 1 minute is 1/60th of a degree. So 1 minute is 1/60th of a degree. So 1 minute is 1/60th of a degree, or 60 minutes is 1 degree. 1 second is 1/60th of a minute. So 1 second is 1/60th of a minute. Therefore, it's 1/3600th of a degree. So 60 seconds is 1 degree. You're like, what the hell are you talking? What are you talking about? Don't worry, I'll break it down as soon as we go through these examples. Okay, before we talk about the minute, degree, second thing, let's add them. Let's learn how to perform calculations with degrees, seconds, and minutes. All right, so let's calculate with degrees, minutes, and seconds, perform each calculation. So we have 51 degrees, 29 minutes, and then we have 32 degrees, 46 minutes. So we're going to add these how we usually add numbers. We have 51 degrees, 29 minutes, 32 degrees, 46 minutes, and we're going to add them. So just how we do everything in math, everything like terms, x goes with x, y goes with y, degree goes with degree, minutes goes with minutes, seconds go with seconds. So we do 29 degrees plus 46 degrees, that's minutes. 29 minutes plus 46 minutes, that's 75 minutes. 51 degrees plus 32 degrees is 83 degrees. But it tells us that 60 minutes is 1 degree. We have 75 minutes here. We're not allowed to have that. We're not allowed to have that there. We have to transform it into 60. So what we'll do is you take your degree as is. So we have 83 degrees. Now for our 75, that's 1 degree and 15 minutes. Because 1 degree is 60 minutes, and then we also have that extra 15. That's what gives us the 75. So 75 minutes is 1 degree, 15 minutes. And now we can go ahead and add them. So we have 15 minutes and 83 degrees plus 1 degree, we get 84 degrees. Could you do this with your calculator? Oh, you bet. Okay, so pause the video, go get your calculator. Okay, welcome back. If you didn't have it, always have your calculator before you start these videos because we're going to use it almost every day. We'll use it almost every day. Okay, so with our calculator, I'll show you. So this handy dandy calculator that's on my screen, you can download it and use it for every test. But remember, don't cheat, only use the calculator. Don't Google stuff, don't do anything like that. But you are allowed to use this calculator. If you look under announcements, it's there for you already. You can download it. It's super simple to download and it's free. If you're in this class, by the way, you should just already own one of these. You should. Just hands down, you should own a TI-84, any type of 84. No Inspire. Nobody uses an Inspire, so don't buy one. Because no one knows how to use it. I don't know how to use an Inspire. All right, so with our calculator on, we need 51 degrees, 29 minutes. So I'm not going to write down the steps. This is something where you might have to pause the video and write down the steps yourself as I'm saying them. All right, so we have 51 degrees, so 51. And how do we get the degrees? It's second apps. Number 1 is your degrees. Then we have 29 minutes, so 29. And to get minutes, it's second apps, and it's number 2. So you hit number 2. Then we need to add that to 32 degrees, so second apps, number 1, 46 minutes, so 46, and then to get minutes, we hit second apps, it's number 2, and we get a decimal. We do not work with decimals. How do we know that? Because it says degrees, minutes, seconds. It says degrees, minutes, seconds. Also, do you notice when they ask the question, they ask using no decimals? It's degrees and minutes. So how they ask is how you should write down your answer. So we need to get degrees and minutes out of this. We already have the degrees, it's 84, we knew that. But to get degrees and minutes, you're going to hit second apps. You see number 4, how it says DMS? That means degrees, minutes, seconds. So hit number 4 and hit enter. Boom. Done. It does it for you. If it's 0 for the seconds, don't worry about it. Don't write it. So it would just be 84 degrees, 15 minutes. Yes, you are allowed to do this with your calculator on the test, or you can do it by hand, however works best for you. All right, so we need to do that again for B. I'm going to do it by hand, and then I'll show you with the calculator. All right, so first by hand. This is actually really, really, really important. It's something that does come back. It's kind of like an idea that comes back. All right, so we have 90 degrees. We're going to subtract that to 73 degrees, 12 minutes. Usually when we add and subtract using decimals and stuff like that, don't we have to have the placeholders? Don't we put like 0.00? We do, but we're not allowed to put 0.00 here. We're not allowed to do that. So we can actually change the way this looks. So we need this. We need something to go here. We need a placeholder right there. So what we do is we know that 1 degree is 60 minutes. So what I'll do is change 90 degrees. We'll change it to 89 degrees and 60 minutes. Because isn't 60 minutes the same thing as 1 degree? So 89 degrees plus 1 degree, we still have 90 degrees. We just changed the way it looked. So we're going to change this to 89 degrees, 60 minutes, and we're going to subtract that to 73 degrees, 12 minutes. So we subtract it down, 60 minus 12, we get 48. 89 minus 73, we get 16. So we have 16 degrees, 48 minutes. Now this is one that I really suggest you always do by hand when you have to convert, because it's something that does come back. But if you're like, oh, I get it, I know how to convert, I get this, like I get it, that's fine. go ahead, use your calculator. So I'll show you with your calculator. Of course, I can't tell you what to do. Do whatever makes you feel comfortable. So we have 90 degrees. So 90 second apps, enter. That's going to give us our degrees. Then we need to subtract that to 73 second apps, enter. 12 minutes, so 1, 2, second apps, number 2 to get minutes. Now, we're not allowed to have decimals. We need degrees and minutes here. So to get degrees in minutes, you hit second apps, DMS, so hit number 4, and hit enter. There we go, all done for us. Isn't calculator nice? I'm going to show you some awesome things with our calculator this semester, so brace yourself. If you don't have a calculator, buy one. You can get them used on eBay for like 40, 50 bucks, or you can buy them new for like 120. It's up to you. But don't get an Inspire. That's my biggest advice. Do not get an Inspire. No one uses them. All right. So let's convert between angle measures. We're going to convert 74 degrees, 8 minutes, 14 seconds to decimal degrees to the nearest thousandth. So now we're converting degrees, minutes, seconds, and we want decimals now. Now we want decimals. So I'm going to show you by hand, and then I'll show you with our handy dandy calculator. Okay. So the degrees, we never touch. It's going to stay 74. So 74 degrees. Then we need to add that to 8 minutes. So isn't 8 minutes an eighth of a degree? It's an eighth of a degree. Because 1 degree is 1 minute is 1/60th of a degree. 1 minute is 1/60th of a degree. So if we have 8 minutes, it's 8/60th of a degree. Then we're going to add that. So we're going to have something over 4, so we're at 14 over something. So we need to convert this to degrees somehow. 1 second, which is 1/60th of a minute, is the same thing as 1 over 3,600th of a degree. That's hard to say with the th part, the 1 over 3,600th of a degree. You get what I'm trying to say, though. So we're going to we're going to divide by 3,600. That's what's going to give us the proportion to the degree. So minutes is always over 60. Seconds is always over 3,600. So we use our calculator. So we have 74 degrees. So 8 divided by 60, we get 0.133 degrees. 14 divided by 3,600, we get 0.0039 degrees. You add all of these up, and we get 74.137 degrees, about. It says round to the nearest thousandth. That's why it's 3 decimal places. A few things I want us to notice. Do you notice here to here it's times 60? Because isn't a second to get to a minute, isn't it 60? And then 60 minutes are in an hour. And the hour is 1 degree. So if you want to think of as a degree as an hour when you're talking about converting, you can think of it that way. Now, how do we do this with our calculator? I'll show you how to do this with our calculator. All right, so with our handy dandy calculator, we have 74 degrees. So second apps, enter. 8 seconds, so 0, 8. Yes, you have to put 0, 8. 0, 8 seconds, so second apps, hit number 2. Then we have 14 seconds. How do we get seconds? It's alpha, green button, and then you see right above the entry, it has 2 little green marks right there. That's your seconds. Hit enter. Boom, there we go. We get it, 74.137. Awesome, right? I think it is. All right, let's go backwards now. So we're going to convert degree, minutes, seconds. So this is one you have to write. I forgot to put it in. It might be there, it might not. I don't know. I only teach this class one semester a whole year. So pause the video, go ahead and write this if you don't already have it. Alrighty, so let's convert this to degrees, minutes, seconds. So of course, I'm going to show you by hand, and then I'll show you using our calculator. So the degree never changes. Keep it 34. That's going to stay the same. So we have 34 degrees. Then we need to add that to the leftover. The leftover is 0.817 degrees. So we just split it up. So how did we get from minutes to degrees? Didn't we divide by 60? So aren't we doing the opposite now? So the opposite of division would be multiplication. So we need to multiply this by 60. Because 60 minutes is 1 degree. So we have 34 degrees plus 49.02 minutes. So now we have minutes. Let's separate it one more time because we need seconds. So we have 34 degrees, 49 seconds plus 0.02 seconds. Now I need to, minutes. 49 minutes and 0.02 minutes. Now we need to get to seconds. So how do we get to seconds? Remember, we're coming from minutes. We are not coming from degrees. At this point, we have minutes. So how many minutes are in a second? Well, we divide by 60. So the opposite of dividing, to get to seconds, we need to multiply by 60. So we're going to multiply by 60. So we have 34 degrees, 49 minutes, plus, so 0.02 times 60, we get 1.2 seconds. The decimal afterwards, don't even worry about. That is just like extra. It's extra. So we have 34 degrees, 49 minutes, and we have 1 second. So 1 is 0, 1. Just like we did 8. Up here, you see how the 8, it was 0, 8. So anytime you have one digit, you have to put the 0 in front. And there's our answer. Let's do this with our handy dandy calculator. All right, so let's type it in as is. So we have 34.817 degrees. So second apps, enter. Hit enter. And then we're going to do second apps number 4. There we go. We have 34, 49, 1. Remember that extra little decimal, it doesn't matter because we don't go past minutes or seconds. We don't go past seconds, so that little extra decimal goes away. If say we had, okay, this is not right? We don't have this. Say we had 1.6. Yes, we would round this to 0.2. So round if you can, but we don't round because it's 0.2. Alrighty. An angle is in standard position if its vertex is at the origin and its initial side lies along the positive x-axis. So this is called standard position, where your initial side is on that x-axis, it's coming from the origin, and your terminal side is what's moving. Quadrantal angles. So quadrantal angles, they're angles in standard position whose terminal side lies along the x-axis or y-axis, such as angles with measures 90, 180, 270, and so on are called quadrantal angles. So what the heck does that mean? So that means if we had an angle that went like this, or an angle that went like this, or an angle that went like this, and so on. And so on and so on. So they're angles that fall perfectly on one of the axes. Coterminal angles. A complete rotation of an array results in an angle measuring 360 degrees. By continuing the rotation, angles of measure larger than 360 can be produced. Such angles are called coterminal angles. The measure of coterminal angles differ by a multiple of 360. So this is what a 420 degree angle would look like, how we're just rotating, and we stop here. So we stop here, but it's the same thing as a 60 degree angle. So a 420 degree angle is exactly the same thing as a 60 degree angle. So an 830-degree angle, we're spinning, we're spinning, we're spinning, we're spinning, we stop. So an 830-degree angle is the same thing as a 110-degree angle. We're going to find the angle of least positive measure coterminal with an angle of 908 degrees. So to find the angle of least positive measure of a coterminal angle, what that means is you want an angle So you want an angle that is between 0 and 360 degrees. So you want your angle, aka theta, between 0 and 360. So that means we need to just subtract or add to 360 by 360 until we get into that range. So let's talk about A. So we have a coterminal angle of 908 degrees. We're just going to keep subtracting by 360 until we get somewhere between 0 and 360. So we're going to subtract by 360 degrees. And when we do, we're left with 548 degrees. That it's not in between 0 and 360 yet, so we need to subtract again. So we subtract by 360 degrees, and then we get 188 degrees. So awesome, that's where it works. It's between 0 and 360. So that is the coterminal angle. Now I'm going to show you kind of what that looks like. You don't have to draw it out. You don't have to draw this out. I'm just going to show you what it looks like. So we have our coordinate plane. So a 908-degree angle. I'll draw that for you. There we go. How do I know to draw two spirals? Because I subtracted by 360 two times. So I have two complete circles. So it ends up at 188 degrees. So a 908-degree angle is the same exact thing to a 188-degree angle. Okay. We subtracted by 360 to 908 because this was bigger than 360. If it's a negative number, you add 360 until you get something between 0 and 360. So if you feel comfortable, I want you to go ahead and try B. Just get that coterminal angle, try B. Go ahead, pause it. Okay, welcome back. I hope you did. My biggest advice, remember, we're not in class. No one can see you. Hopefully. Hopefully no one can see you. So hopefully that makes you feel a little bit better that, hey, no one knows if you get it wrong. You're the only person that knows that if you get it wrong or right. All right, so let's find the least positive measure coterminal with an angle of negative 75 degrees. So we're going to treat this the same exact way, but except we're going to add 360 because it's negative. So we're going to add by 360. And when we do, we get 285 degrees. So that is in between 0 and 360. So that is our coterminal angle. Now I'll show you what that looks like. You don't have to draw it, but I'm going to show you. So we have our angle of negative 75. So negative 75, that's about there. So it's the same thing as an angle that's 285 degrees. Coterminal angles are super duper important in this class. So practice, practice, practice with them. All right, example 6. A constant angular velocity disk drive spins a disk at a constant speed. So meaning it's just spinning at the same speed. Suppose a disk makes 480 revolutions per minute. Through how many degrees will a point on the edge of a disk move in 2 seconds? Okay, so this is asking, we have 480 revolutions per minute. So that disk is spinning 480 times per minute. We want to know how many degrees does it spin? Because each revolution, that's 360 degrees. Remember, a revolution is 360 degrees. But that's per minute. So it does 480 full rotations per minute. I want to know how many degrees does it rotate in 2 seconds. So a disk revolves, it tells us 480 times per minute. So 480 times per minute, I want to know per second because we're talking about 2 seconds. So I want to convert this to seconds now. So we do 480 divided by 60 and we get 8 times per second. So that means per second it rotates 8 times per second. Now we want to know how many degrees will it be in 2 seconds. So 2 seconds. So if it's 8 in 1 second, in 2 seconds it would be 16. So we do 8 times 2 and we get 16. So that's 16 per 2 seconds, but that's not degrees because we're not working with degrees right now, are we? Nope, we're working with seconds. We're working with that. So to get to per how many revolutions, how many degrees? Since we're talking about revolutions, a revolution is 360 degrees. Remember that? So we need to multiply 16 by 360 degrees. So we get 5,760 degrees. So yes, it rotates 16 times. So that means it's rotating 16 times. 16 times is 5,760 degrees. All right, below is just the Greek alphabet. We use several things from the Greek alphabet. Like we use, where are you? Theta. We use theta. We use this theta, lowercase. We use lowercase theta. In math, I'm sure you've seen that sign. It means delta. Delta, this little triangle, just means average rate of change. That's all that is. So if you're talking about a line, the average rate of change, the delta, is just the slope. So this is here for you, just so if you see a variable you've never seen before, you can go back and say, oh, okay, it's just pi, or it's kappa, or it's gamma, or it's delta, and so on.